Be talking about the tracks. You guys probably already know that there's different types of tracks. You have ascending and descending pathways. Or should already know. The ascending pathways are sensory and the descending pathways are motor. The ascending pathways, obviously the sensory, because if you touch your hand, then the sensation will go from your hand upwards, or ascending to your brain. And descending is you have signals sent from your brain downwards to your hands, so that's the motor pathway. Okay, so in this video I'm going to be talking about the sensory pathway, and the first thing you should do is actually get a big piece of paper, and what I'm going to do is tell you the different type of pathways that you have and draw it all out on one piece of paper instead of actually drawing one pathway and another pathway and another pathway in one different piece of paper. You get confused. If you write it all pathways on one piece of paper, you can visually compare them as well and remember, oh, this is this pathway, this is this pathway, and this is this pathway. So I'm going to begin by telling you the different types of sensory pathways that we actually have. So not only different type of sensory pathways, but the different type of sensations. So the first one I'd like to talk about is the dorsal column pathway. You can also call it the dorsal column medial lemniscus pathway, but for short I'm just going to call it the dorsal column pathway. The second one I'm going to be calling, or it's called the anterolateral system. And the third one is going to be called the spinal cerebellar pathway. Okay? So with these pathways, there's sensations for different types of things. So for the dorsal column pathway, it's for fine touch. Okay? The anterolateral system, on the other hand, it's for crude touch and pain and temperature. And the spinal cerebellar pathway is for something called proprioception. Proprioception. Okay? Proprioception is basically when you move your hand, you don't have to look at your hand where it is. You already know it's behind your back or something. You can Google the word anyways and you would understand what it means. Anyways, so these are the different types of sensations that you have, but within these pathways, you have different types of tracks. So for instance, here you have the cuneate tract, or you can call it the fasciculus. So I'm going to call it the fasciculus. The gracile fasciculus. I'll just say the cuneate and the gracile, okay? The anterolateral system, you're going to have an anterior, so these are called cuneate fasciculus. And the tracks, yeah. Anterior, and these are called spinal thalamic tracts. Yeah, so you have the anterior spinal thalamic tract and the lateral spinal thalamic. Why is it spinal thalamic? It's because it's going from the spine to the thalamus. Yeah, anterior spinal thalamic tract and lateral. Spinal cerebellar pathway, on the other hand, you have three. That's the anterior, or you can call it the ventral, because anterior and ventral are the same thing. Well, not the same thing, but yeah, pretty much the same thing. And spinal cerebellar. Yeah, I can't be asked to describe to you the difference, but you can find it on Google. Anterior and ventral are pretty much the same thing. And then you have the posterior, or you can call it a dorsal spinal cerebellar, and the cuneal cerebellar. Okay, so now this is just laying out the foundations that you know that you have three different types of sensations: fine touch, crude touch, and proprioception. But you have two pathways here, two pathways here, and three pathways here. So this is what you're gonna remember, okay? And when I draw it out for you, everything's gonna be complete here, and you can see the differences. So what am I gonna do now? I'm gonna draw. So I'm gonna draw the cross section. I'm gonna draw the cross section of the spinal cord. You should already know what a cross section looks like. So I want to get a picture actually here. So this cross section of the spinal cord. the grey matter here, and then you have the white matter on the outside. The white matter is where the tracks are running through, remember? That's where the axons are running through. So we're looking at the ascending tract today, the sensory, so we're going to look at this half. You can see in the white matter, you have these little shaded areas. Here, you have the fasciculus gracilis, fasciculus cuneatus, yeah, which is this part here. Then the next part, so this whole region is the dorsal column pathway. This part here, you have the anterior spinothalamic and lateral spinothalamic. So this region here, the anterolateral system. And then you have the anterior and the posterior spinocerebellar tract. So this is going to be the spinocerebellar pathway. Yeah. I'm showing you this diagram, so when I draw it, I will draw you the tract as well. You understand when I draw it. So let's start. For the first one, for instance, we have, so this is the cross section of the spinal cord, and I want to draw to you the grey matter. So if this is the grey matter here, where was the dorsal column pathway? It was here, posteriorly. Yeah. So I'm going to draw this region here. The thing is, you have the right and left side. You have a medial portion here and a lateral portion. Okay. I want to shade in the medial portion here. Okay. A medial portion on this side as well. So this whole thing is the cross section and the dorsal column pathway. I'll say this is the level of the leg. Okay. So you know, and I'm going to draw another cross section now, but the level of this cross section is going to be higher. So you can imagine I'm drawing a spinal cord as you go upwards. Okay. So this is the dorsal column pathway, but I'm shading the lateral part of the dorsal column tracts, yeah? And this is the level of, for instance, the arm, okay? Now, what are we going to do here? If we have a touch in your feet, so this is going to be a foot, weird foot, but anyways, your sensations is from the gracer or gracilis. If you have sensations of the hands, then the upper limb is from the cunei. Okay? And we're going to look at the difference in the pathway in a moment. The next part I want to draw is the level of the medulla. And this is, I'm just going to draw medulla like this. Okay? And then I'm going to draw the brain. Okay? That's the brain, cross section, and it's the thalamus here, and where's the thalamus, guys? Do you remember? On the side of the third ventricle. Anyways, that's just the review of before. So the grey cell, so this is the dorsal column pathway. I'm going to be now describing the pathway. So we have some nerves that come and enter through the dorsal root. So what is the dorsal root? It's this section here. The ventral root is here. That's for motor fibers. So motor is in the ventral part. But we're talking about the dorsal part today because we're talking about sensory. So the dorsal root, once it enters, it goes to the dorsal column and ascends up. But on which part? The medial side. Because the medial side is for the lower limbs and the lateral side is for the upper limbs. Okay? As you go more and more higher, you go more and more lateral. Okay? So dorsal root comes in. I'm going to draw this, by the way. This is the cell body or the dorsal root ganglion, yeah, of this nerve. Dorsal root ganglion is just basically the cell body of this nerve. Now it's going to ascend up. Once it ascends up through this is called the gracile fasciculus. Yeah. Once it so the ascending part nerve or tract is called the gracile fasciculus. then you'll find that there's nuclei in the medulla. Okay, the nuclei, let's remember, is what the cell body of the nerve. Then you have the axon coming out from it. Okay, so the gray cell fasciculus is ascending upwards. At the level of medulla, it will synapse. So now this is one neuron. This is called the first order neuron. First order neuron. And once it synapses, it now is becoming the second order neuron. So, or you can think of it as a second neuron, okay? So once what happens is, if this is the midline, it crosses over to the other side. If this is the left side, it crosses over to the right side. And then continues to ascend up. Once it ascends up, it synapses at the thalamus, okay? Now, once it synapses the thalamus will project the fibers to the postcentral gyrus. Okay, so let me give you more of a description, okay? Or let me actually explain to you one more thing. The postcentral gyrus is over here, and it's actually a map of the human body. So if I draw you the feet here, and it's the hands, and it's the head. The more medial side is the feet, and as you go more lateral, it goes more higher and higher in the body. Okay, so because it's the feet, I have to send these fibers to the medial side. Okay, so let's name these parts. So this is the dorsal, it's entering through the dorsal root, and then it enters this dorsal column pathway. It ascends up as the gray cell fasciculus. It synapses at the gray cell nucleus. Yeah? And then it decussates. Decussate, so decussate, that just means it crosses over, okay? And these fibers actually have a name. They're called the internal arcuate fibers. So they decussate, and this forms the internal arcuate fibers. If I draw an arrow here, internal arcuate fibers, and it forms this tract. This is now called the medial lemniscus. Okay, so this is called the medial lemniscus. It ascends up to the thalamus, and then it will synapse at the VPL. After the VPL, it will go through something called the internal capsule, more specifically the posterior limb of the internal capsule, to the postcentral gyrus. Okay, I've labeled everything here. And then, so it's always good to write out everything in words as well, so you can actually see the words of what's actually happening. So you can imagine what's going on here. But to break it down, so the gray cell, it enters, once it enters, it goes up as the gray cell fasciculus, synapses at the gray cell nucleus, forms decussates as the internal arcuate fibers, and it sends up as the medial lemniscus. So you can see all the pathway here. Then obviously VPL through the internal capsule and to the postcentral gyrus. But these are the main parts you need to know. The fasciculus is first, then nucleus, decussates after at the level of the medulla, and then forms the medial lemniscus and goes to the VPL. Okay? Alright. So this is the lower limb. Now for the upper limb, it's pretty much the same thing, except, as I said, the dorsal column is more lateral for the upper limb. So it goes in through the dorsal root, which is the back part of the spine. And once it goes in, it ascends up on the lateral portion of the dorsal column. This is the cell body of the first order neuron. Then it goes up. There's going to also be a nucleus for the cunate fasciculus, and this is called the I want to draw it on the right here, cuneate nucleus. Yeah. Same things happen. It goes, the cussates as the internal arcuate fibers and goes up the medial lemniscus. Goes to the thalamus where the third order neuron is. So you can have a nucleus here. What's the nucleus? The cell body for this third neuron. But when I draw it, I'm going to draw it over here. Yeah, because it's the hand on the postcentral gyrus, it's going to be more lateral. More lateral, okay? Okay, so it goes to the VPL. VPL was ventral, posterior, lateral nucleus. Okay, which is in the thalamus, okay? In the thalamus. So where does it synapses? The first synapse is the medulla, the second synapse is the thalamus. Okay? So this is the first pathway that we've covered. This is for what? Fine touch. There's two divisions, cuneate and gracilis, or yeah, gracile or cuneate fasciculus. The gracile is for the feet or lower limbs. The cuneate is for the upper limbs. So this is the divisions. Now we can go on to look at the anterolateral system, and this is for crude touch, pain and temperature. Oh, let me write down here what it's for. So the cuneate was for the arm or upper limb, and gracile was for the leg, for instance lower limb. So lower limb, upper limb. So the anterior spinal thalamic tract, what is this for? And it's for crude touch. Crude touch. Yeah. Lateral spinal thalamic tract, on the other hand, is for pain and temperature. Okay? Now, you can remember however you want to remember it, but I just remember anterior spinal thalamic tract is A is like the first letter of the alphabet, and then there's crude touch, pain and temperature. But which one is it? Is it crude touch or pain and temperature? Or C is also closer to the first letters of the alphabet. So that's how I remember it. A is with C. You can remember however you want to remember it, but this is how I do it. Anyways, this is the level of the leg. So I'm going to draw, well, to be honest, with this, it doesn't matter what level it is. So crude touch, pain and temperature is at all levels, yeah? Okay, what do I mean by this? Let me just show you. So if this is this, and I want to draw the medulla here, and then the okay, that didn't look too good, but anyways, okay, so here, this one's going to be, so this one was cuneate fasciculus or pathway, and this is gracile pathway and cuneate pathway. Here we have the anterior spinal thalamic tract. So anterior spinal thalamic tract, and I want to draw to you the grey matter. Now again, we drew here the tracks on this cross section. Here I'm also going to draw the tracks in this cross section, and the tracks are found here. Okay, this is the anterior one, and it's the lateral one. If you want me to show you the book again, here you go, anterior and lateral. Okay, it's just closely to the horn of the nucleus, the grey matter. So the grey matter, you have the ventral horn, which is the anterior horn, and you have the posterior horn, or dorsal horn. Yeah. So this is how you divide the grey matter. It looks like a butterfly or whatnot, or H, they say some people. This is the back part of it, and it's the anterior part of it. Yeah. So dorsal horn, ventral horn. Yeah. Okay. So anterior spinal thalamic, what is it for? Crude touch. So I can draw anything. I can draw a hand or a foot. It doesn't matter. It's for both the hand and foot, whichever level. and then it enters through the dorsal root, so the behind. Again, this is the nucleus, the ganglion, because it's outside the CNS, it's called ganglion. So the dorsal root ganglion, yeah. So the cell body of this nerve. Once it enters, it synapses instantly at the dorsal horn. So if this is the first neuron, this now a synapse is become the second order neuron, like almost instantly as it enters. And then the fibers decussate straight away. So it decussates at the level of entering, it just decussates. And then it will ascend upwards. Let me draw the thing here as well. So it's just going to ascend upwards in the anterior spinothalamic tract. It's going through the anterior again, spinothalamic tract. And what happens? Nothing happens in the medulla. It keeps going up. And then once it goes up, again, it goes to the thalamus and synapses at the thalamus. Okay? Once it synapses at the thalamus, at what nucleus? The VPL again. All of these are going to be the VPL, okay? VPL, you'll come across another one called VPM, but that's something else. And that I'm going to talk about later in another video. Okay, so what was I saying? First order neuron comes in through the dorsal root, synapses the dorsal horn, decussates, so crosses over, and ascends up so this is called the anterior spinal, the name of this is the anterior spinothalamic tract. The anterior spinothalamic tract keeps ascending up to the thalamus, and then it synapses at the thalamus, VPL, and goes to the postcentral gyrus, okay, through the internal capsule. Yeah. So this third order neuron now goes to the postcentral gyrus through the posterior limb of the internal capsule. Okay. So this here was the anterior spinothalamic tract for crude touch. Now let's take a look at the lateral spinothalamic tract. And what is it for? Pain and temperature. Now, I can draw the hand and foot, it doesn't matter. So at all levels, it will enter. Once it enters through the dorsal root, it will synapse again at the dorsal horn and decussate over, entering the lateral spinothalamic tract. So this obviously is going to be called the lateral spinothalamic tract. It's going to go upwards, and same thing, synapse to the thalamus and synapse to meet the third order neuron to the postcentral gyrus. It doesn't matter if I'm going medial or lateral here. So because it's more lateral, what is this? It's more higher in the body, so it could be the hand, for instance. Here it's going to be more medial, so where could this be? I don't know. The butt, the arse or something. It could be anywhere. So lower than arm. So here there's no synapse or any like interaction with the medulla. It just goes straight up. Okay. Well, there is actually interaction with the medulla, but I will talk. This is like extra information, so I don't want to talk about it now because it confuses everything. Right now, this is a very simplified drawing for you. I will go into detail at the end when I finish drawing all three. So again, what happens? First order neuron enters, synapses at the dorsal horn, decussates, goes up through the anterior spinothalamic tract to the thalamus, VPL, synapses, goes to postcentral gyrus. Okay. The fibers here, A delta, C fibers, yeah? Because A delta and C fibers are for pain, equals pain, yeah? Okay. So, now we're going to talk about the spinal cerebellar pathway. What is the spinal cerebellar pathway for? Proprioception. So there's two pathways here, but I have three pathways here, so I'm going to have to fit three cross sections here, okay? So that's what I want to do. Can you see here? Here you can. Okay, so I want to draw a cross section here. So bang, cross section here. You realize why I drew these together at the leg, leveled leg in a moment. And then here is the third one. Okay. And then we're gonna draw the medulla. Okay, I'm not gonna draw the cerebral cortex. Okay, for this one now, it says spinal cerebellar. So as you probably know, it's not gonna go to the thalamus because this is spinal thalamic or the cortex. Instead, it's gonna go to the cerebellum. So I need to talk about some stuff before talking about this because I don't know if you guys know the relation of the cerebellum to the brainstem. So if I was to draw you a side view or lateral view of the CNS, so this is the cortex, cerebellum just underneath it here. This is the spinal cord, but in the spinal cord you have the brainstem here, so you have the midbrain, the pons, and the medulla. Okay, so midbrain, pons, and the medulla. And these three structures are actually related to the cerebellum because they send fibers. So the midbrain sends fibers to the cerebellum, pons sends fibers, and the medulla sends fibers. This red thing that I've just drawn is the fibers that go, and they form a structure called the peduncles. Okay, so the peduncles, so from the midbrain to the cerebellum is going to be called the superior peduncle. From the pons is called the middle peduncle, and from the medulla is going to be the inferior. It's quite easy because it's just in the order where they are. So superior for the midbrain, middle for the pons, and inferior for the medulla. You guys might know this already, but yeah, you should know this. This is the basics. So this midbrain is related to the cerebellum, so the brainstem. So this is the medulla. I'm gonna have to draw on the side of it, just the cerebellum over here. So this is the cerebellum, so cerebellum. Okay, I'm gonna draw the pons here and the midbrain here. Okay, and it's the cerebellum just behind it, or it's even lateral because it sticks out a bit laterally. I'm gonna rub this out because this is just for explanation purposes. So the brainstem, is made up of the midbrain, pons, and medulla, and it connects to the cerebellum through something called peduncles. Yeah, and you have a superior, middle, and inferior one. Anyways, we are going to talk about these different types of tracts. So you have the ventral, spinal, cerebellar tract, or anterior, whichever you want to call it. So I just call it anterior spinal cerebellar here. We can have the posterior spinal cerebellar here, and then finally the cuneo cerebellar. Okay, now you're thinking, okay, it's proprioception, but why is there three? Well, this one, the cuneo cerebellar, is going to be for the upper limb or arms. I'm sure arm, and these two here are going to be for the lower limb, so I'm just going to write leg. So that's why I drew it at level leg. These two leg, this one is up there. Okay, I'm not going to describe from this one upwards. I'm going to start actually with the posterior spinal cerebellar. Okay, and I'll explain why in a moment. And again, as always, I want to highlight where the tracks are found. Okay, so here's the tracks. Well, actually, this one has that. Okay, if you want to see the book, it's the book. Here you go, anterior, posterior spinal cerebellar tract. Okay, so let's talk about the posterior spinal cerebellar tract. Again, Because it's sensory, it's going to enter through the dorsal root. Once it enters, it will synapse at the dorsal horn here, and then it will not decussate. It actually stays on the same side, and it's going to go to the posterior spinocerebellar tract. Okay, what you need to know for this posterior spinocerebellar tract, this where it synapses has a special name. Okay, it's called the Clark nucleus. Okay, the Clark nucleus. The Clark nucleus. What happens is that's just the name of it. Once it synapses at the Clark nucleus, you have the second order neuron, so the second neuron, and then that will ascend upwards through that doesn't exist. It will go up to the badly up into the medulla, and at the medulla, what happens is you're going to have, what did I say? These peduncles, remember? Superior peduncle, middle peduncle, and inferior peduncle that connects the brainstem to the cerebellum. What's going to happen is that the posterior spinocerebellar tract goes to the medulla and enters through these peduncles to go to the cerebellum. So how does it go to the cerebellum? Through the peduncles. At what level does this posterior spinocerebellar tract enter the cerebellum? At the level of the medulla. Okay? So again, enters through the dorsal root, synapses at the Clark nucleus, ascends upwards. So this is obviously called the posterior spinocerebellar tract, this ascending tract, and it's going to go up to the medulla. At the level of the medulla, it's going to go to the cerebellum. So that's the posterior spinocerebellar tract. Okay. Now, on the other hand, this one, the Clark nucleus, you can call it another name. It's also called the posterior thoracic nucleus. So you can also call it the posterior thoracic nucleus. Actually, I should write this clearer because I might take a picture of this after. Thoracic. Yeah. I hope you can read my writing. Anyways, posterior thoracic nucleus or Clark nucleus. And then it goes to the cerebellum. Now we're going to talk about the cuneo-cerebellar, okay? Yeah, I'll talk about this one. The cuneo-cerebellar is going to enter through the dorsal root, but on the other hand, it's not going to synapse at the dorsal horn. Instead, you can probably guess it's called cuneo. So this is the dorsal column pathway. It's going to enter through remember the cuneate fasciculus? It's actually going to ascend on this section here and ascend upwards. That's why it's cuneo, because it's cuneatus. So it ascends upwards, and in the medulla, it's going to synapse at this nucleus here, and then enter the cerebellum. Yeah, through what? The inferior peduncle. Now, what's this nucleus called? The name for it is the accessory cuneate nucleus. Okay, where is it found? Medulla. Okay, quite important, it's medulla. The accessory cuneate nucleus is basically the same thing as a Clark nucleus, but in the brainstem. So they call it a homologue. So the Clark nucleus is a homologue of the accessory cuneate nucleus is a homologue of the Clark nucleus. Okay, so the Clark nucleus continuation of the Clark nucleus grey matter up into the medulla. So the medulla has a different name. It's called the accessory cuneate nucleus. Okay, this one, take note, it did not synapse at the level of where it entered. Instead, it goes up into the medulla, and that's when it synapses. The cuneo should give you the idea, or to make you remember that it's going to go to the, or that it's got a different name, so it's going to go to medulla. Anyways, the anterior spinal cerebella is a different one, okay? I want to draw the tracks on the other side, and you'll realize why in a moment, because once it enters, it's the same as the posterior. It's going to synapse at the the dorsal horn, but it's going to cross over. Once it crosses over, it's going to go into the anterior spinal cerebella and ascend upwards. But when it ascends upwards, it doesn't go through the inferior peduncle. Instead, it's going to go through the... See? Check this out. You know this side? Once it's gone in, it stayed on the same side and it goes up. So if it started from the left, it goes up on the left and then it enters through the left peduncle. This one, it goes, decussates over to the right side, goes up, but then what happens is that it doesn't go to the right side, it comes back and enters the left side. So it enters the left side, might have decussated, but it still goes back into the left side of the cerebellum. So what do you have to remember? The spinal cerebellar pathway is ipsilateral, okay? So what that means is that where it enters, the side it enters is going to enter the cerebellum on the same side, okay? It's not going to be in different sides. Even though this one decussates, it will decussate back at the superior peduncle and enter back the cerebellum. These ones enter through the inferior, yeah? So, and this one is going to be synapsing at the medulla, okay? So here are the three. So I had to record this again because I did a mistake. Don't worry about this additional stuff, that'll be drawn later on. So to cut this video and say that the anterior spinal cerebella, when it enters and it decussates at the level of entry, when it goes up on the contralateral side, that means the other side, because it entered the left, it goes up on the right side, that means the contralateral to the left. So enters in left, goes up the right. What happens is it would then go into the cerebellum on the right side. So if I was to draw peduncle there, goes through the superior peduncle onto the right side, but it still ends up on the left side because within the cerebellum it will cross over to the left side. It does so by fibers called mossy fibers. Then we need to know that bit. This is additional, but mossy fibers is how it crosses over to the other side, back to the same side it came from, within the cerebellum. Yeah, right. So I want to go into more detail about the pain. This part of the video you do not really need to know, but for purposes of, I don't know if you guys want to know, I'm going to explain it to you anyways. Okay, so the first things first is that pain has, I'm drawing green because it's just additional stuff, it has an emotional aspect to it, a physiological aspect to it. So when you feel pain, then you're increasing heart rate or something like that, yeah? So it goes through the ANS, so the autonomic nervous system, or the sympathetic nervous system. And another portion of it is consciousness. Because obviously if you're sleeping or you're chilling and then I pinch you, and then obviously you just become alerted and your consciousness would increase, yeah? So what, oh, and there's another one as well, spinal tectal pathway as well as part of it. The tectum is part of the midbrain. It's the superior and inferior colliculus. It's the posterior part of it. If you know the anatomy of the brainstem, then you may already know what the tectum is. But you have a superior and inferior colliculus. The superior one is for the eyes. Yeah. So what happens is this goes to the superior colliculus, stimulates it. So if you feel pain, what are you going to do? You can look straight there, right? So it's a reflex. Yeah. So this is for the reflex for your to look in that direction when you feel some pain. Okay. So let's talk about these different sections now. This is all for pain. So it's not in the anterior spinal thalamic tract, it's on the lateral and for pain. So the lateral spinal thalamic tract, it enters, synapses at the dorsal horn, ascends up through the lateral spinal thalamic tract, but it can give fibers to the medulla, to the reticular formation. Okay, so what is the reticular formation? Basically, it's grey matter. So if this is grey matter, and then you know axons from the brain, it cuts this grey matter, and then it becomes like dispersed. So they're just like clusters of grey matter. So I'm just going to draw here the reticular formation. It's just clusters of grey matter. Okay. So this reticular formation is for what? It's for the consciousness. So I'm just going to write RF here. Okay. Reticular formation. So why? Because the reticular formation will then send fibers up into the brain and just like send signals to the brain to alert it so it becomes more conscious. Okay. Now, the next one we're going to talk about, let's go with ANS, physiological. Do you remember where the insula is? The insula is here. Yeah. Oh, this will go, it doesn't matter, it goes any pathway, yeah? Reticular formation. So the lateral, it will send fibers to the insula. And the insula will then cause you to increase heart rate, for instance. Yeah. So the physiological aspect goes to the insula. Now, what about emotions? Do you remember where the cingulate gyrus is? Do you remember the medial side of the brain? You have the cingulate gyrus, and synapses going to the cingulate gyrus gives you that emotional part of the pain, cingulate gyrus. Okay, so I've drawn you these green ones. They're not very important. Okay, I've written here emotional and the gyrus, or the portion of the brain that's responsible for this part of the pain. Spinal tectal is just basically it enters. Once it enters, it's actually situated in between the two. So it will go and ascend up, and it will join the fibers, yeah, of these lateral and anterior spinal thalamic tracts. And the joining of all three actually it actually forms another name. So these three, when they join, is called the spinal lemniscus. Okay, so spinal lemniscus is going to be all three of these: the anterior, the lateral, and the spinal tectal. Okay, but for your colloquium and most of even for your written exam, you won't need to know this green part that I've drawn for you. I've only added this part, I don't know, just because you guys may be interested to know more information about pain. But yeah, I don't think you guys care. But yeah, another thing to say about the lateral spinal thalamic tract is there's something called the tract of Lycia. So what is this? Okay, I forgot to draw these dorsal column, dorsal ganglia. It's bugging me. Anyways, when this fiber comes in through the dorsal root, say it comes in at T2, level T2, the fiber, it doesn't necessarily have to synapse at this nucleus at T2. You could ascend upwards and synapse at T1, or it can descend downwards and synapse at T3. And this is called the tract of Nissia. Okay, the ability to go up or down. And where do you find the tractylisia? So if you saw the spinal cord cross section, I'll show you again in this picture even. So this is the grey matter. The white matter here, this green area, is still white matter because it's a tract. It's the tractylisia. Okay, so it's just close to the dorsal bone. So let's talk to you guys about the sensory pathway as a whole. So we looked at the dorsal column, the anterolateral system, and spinocerebellar, or should I say fine touch, the crude touch, and pain temperature, and the proprioception sensations. Well, where is the sensations found? So I want to draw a body. So this is the head, neck, the upper limb and lower limbs. These three sensations are found in the upper limb, the abdomen, and the lower limbs. So they just cover everything below the neck. So what about the sensations of the head? The sensations on the head, on the other hand, they are sensed by the trigeminal nerve. So the trigeminal system gives you all three of these pathways. So the fine touch, the pain, and the proprioception, yeah, they come from the trigeminal. So it covers all three, and it goes for the head and neck. So anything except for the head and neck is going to be these three. And we've said that whenever it goes to the thalamus, it's always VPL. This doesn't go thalamus, so VPL, VPL. But in the trigeminal, it's actually VPM. And trigeminal system is the next video that I'll be covering. Is the homologous pathway to these sensations, because these sensations are for the limbs, whereas trigeminal is for the head and neck.